let's try this. So I think this will work. Let me make it a little bit trickier. And all right, let's try that. That's about I'll try that. All right. And I will make up some numbers later when we get to that. All right. Call that I, call that V. Okay, and we'll call it IS and VS. All right, so I got 3 switches, so this is pretty weird looking. 2 switches open at t equal to 0 and 1 closes at t equal to 0. Okay. All right. And this is probably a pretty similar one in a lot of ways to problem 4 on the homework. Okay. All right. So I've got a couple of steps. The first step I always say is to write the differential equation for t greater than or equal to 0. Okay. So if I've got this circuit, what's the circuit look like for t greater than or equal to 0? All right. So for t, what would this look like? Not worry about that current source over there. That current source isn't going to have any effect on what the L, R, and C are doing, right? He's off by himself. All right. What about the voltage source? Does that matter?
Yes.
Yes, it does, right? So for t greater than 0, this guy would be basically V sub S. There'd be L, and there'd be R, and there'd be C, like that. And that would be that. Right, that would be our circuit. The other 2 switches would be open. Okay. All right, so let's say I want to do step 1. So step 1 would be to find the ODE, the differential equation for that circuit. So how do I start? Try a lot. What's that? KVL. All right. Well, so first of all, first thing I got to do all the time, it's one thing I see you guys do wrong all the time is you don't define the polarities of everything at the beginning because that's important. Once you define the polarities, you got to stick with them. Okay. So I'm gonna set that up and I'm gonna do KVL as was suggested, right? So I'm gonna do it this way. I'm gonna say I want to do here's IL, here's IR, and here's IC. And then I'm gonna mess with this a little bit. I'm gonna say IC is that way. Okay. All right. And I'm gonna say V sub C is this way. And you guys are probably saying, well, that's a dumb choice, and it is, right? But it's okay, right? As long as everything I do is consistent. All right, so I have V sub L. I should probably have a V sub R too, but what do I know about V sub L and V sub R? What's got to be true about those?
Single sign.
Same voltage across the resistor and the capacitor, or sorry, resistor and inductor. So VL equals VR, like that. Okay. VL equals VR. All right. So now the other thing I need to know is, all of the Ohm's law type of relationships that I'm going to need to be able to solve for this thing. So what are the Ohm's law relationships that I need here? So when I say Ohm's law, basically V equals IR, and then whatever I got for the capacitor and the inductor. So what are those? Yeah. IC, how does that relate to the capacitor voltage? All right. Because I'm being a jerk on this problem, I wrote it as negative CdVs. Right. Now why is it negative? It's going the opposite direction. So I did that on purpose. Again, it doesn't matter, but I just wanted to make sure that I made that point, emphasize that point, that if the arrow is flowing out of the plus terminal, then my passive sign convention tells me I got to write it like that. I got to put a negative sign in it. Okay. Just you learn that for Ohm's law, but it's also true for all these other relationships too. Okay. All right. So what else do I need here? So what's the relationship for the inductor? What's that one? LDI dt. Yep. So VL equals L DIL by dt. And given the way I wrote that one with the polarities, I have the arrow going into the plus terminal. So I make sure that guy's positive. Okay. All right. So I have all those relationships. That should be pretty much all I need at this point. All right. So the suggestion was to write KVL. All right. So here's my circuit again. Here's V sub S. Here's the inductor. Here's the resistor. Here's the capacitor. IC is here. VC is here. That's VL. That's IL. And that's IR. Okay, so let's write KVL. 0 equals. So for me, I start in the bottom left corner. All right, so, and some of you guys might skip the step of saying DS equals something. I don't ever do that. I say 0 equals and I just go around. All right, so if I go around in a clockwise way, think about that, and I start in the bottom corner, I go through the voltage source first. So how do I write the voltage source? I go negative VS because I'm going negative to positive. Okay. So yeah, I always go around clockwise, like that. So I'm going negative VS. And then what do I do when I get to the inductor and the resistor there? Plus VL because I'm going plus to minus. And then I get to the capacitor, what do I do? Plus VC. All right, so I have VS equals VL plus VC. Okay, that should be useful to me later. And I haven't said, what the heck am I solving for? Let's say I want to solve for the, what's that? Yeah, let's solve for I of T. Yeah, let's solve for IL. Yeah.
So because the inductor and resistor is in parallel, you just forget about one of the other. You just put it in the equation.
Yeah, I mean, I could say it's VR plus VC. Those are equivalent statements because VR equals VL, right? Yeah. All right. Yeah, and we'll solve. So I guess back to my original side, we want to solve for IL. Okay. All right. Okay. So if I want to solve for IL, what do I need to do? So I want to get a differential equation. First step is getting a differential equation, right? So if I'm trying to get a differential equation, what should be in my differential equation? Derivatives of what? Derivatives of IL, right? Derivatives of IL. So that means a second derivative, first derivative, and a zero derivative, right? So how do I do that? IL. I don't think I want to do IL, but I'm going to do it anyway, I guess. I think it's going to be weird. So happens I just make it up off that, I guess. But what else do I need? That's not going to be enough for me, probably. Yeah, I'm probably gonna need a KCL here too, right? This guy's a little bit more complicated. So I'm gonna need a KCL. The KCL is gonna be what? Yeah, IL plus IR equals negative IC. Well, let me do it this way. I can do it a couple of different ways, but given the way I wrote it here, right? No, I got yeah, I'll kind of write it this way. It's the same thing, right? IL plus IR equals now I gotta be careful. Negative IC. I'm doing silly things here. All right. What am I? Well, so let's be super careful about this. In terms of what's a node here, I guess I'll just make a dot there for what is the node, right? All of those currents are entering that node as I've written it, right? So IC is entering it, IL is entering, IR is entering, right? So just kind of, I guess, being consistent with the way that I normally write stuff, right? I put all the things entering on one side, all the things leaving on the other side. So this guy basically becomes IL plus IR equals negative IC. Okay. Again, we just get used to, KCLs. You basically all the currents entering equals all the currents leaving, and just stick with whatever directions you chose. All right, that's basically the way to approach it. Okay. All right, now what? I really think I don't want to do IL. I think it's going to work out to be super nasty if I do that. I want to solve for V sub C. I think it's going to, so I want to solve for V sub C. All right, what do I do? How do I approach this? What's that? Yeah, I start using the Ohm's law stuff to substitute in here. So let's look at the I sub L here. I sub L is VL, right? So I sub L is related to V sub L, I sub R is related to V sub L, I sub C is related to V sub C in all different ways, right? So there's a couple of things I could do with that, I guess, right? Let's see. You guys tell me. Where do you think I should start? I want to get to an equation for V sub C. Where should I start? Well, I've got one over there. That seems nice, doesn't it? All right. So VS equals VL plus VC. Let's deal with that one. All right. Does that help me in any way? Maybe it does. All right. Let's say I want a differential equation for V sub C. So this is about as tricky a problem as you're probably going to see. Right? How can I approach this? So I want to work from this guy. So what do we know about V sub L? What's V sub L related to? Yeah, V sub L we wrote over here. V sub L is L di dt. So we could write this as L dIL by dt plus V sub C, like that. Okay. Now, does that help me make a link at all? Any way to make a link here?
C in terms of its current.
Right, what in terms of current?
VFC, the festival.
That wouldn't help me because I'm trying to get to a difference equation for the capacitor voltage. So I'm in good shape. I like having the capacitor voltage already there. Can I get, so IL I want to get rid of. How do I get rid of IL over here? So I'm basically working to get a differential equation from this side. Right. What kind of, how does the other equation help me? How does the KCL help me? Don't I have IL equals negative IC minus IR? Does that help me at all? How can I combine those two now? Yeah.
Can you integrate the right equation to and then to IL to integrate?
I don't need to integrate anything necessarily. I could, but I have IL equals negative IC minus IR. Again, trying to keep our focus on what we're trying to do here. So I want to get an equation for DC. That's got IL in that. I want to get rid of the IL. So what should I do? What about taking that equation and dumping it into this one? What about trying to take this here and put it into here? How could I do that? So this is IL right here. Right? So I just put L d by dt of negative I sub C, negative I sub R, plus V sub C, like that. Okay. You guys with me there? What I just did? Right. Does that help me in any way?
Did you substitute the IC?
IC is CdVdt, right? In fact, in this particular problem, given the goofy way I defined things, IC is actually negative CdVdt. That's going to make a minus sign go away. So basically, let's be real careful with what I got here. I got Vs equals L d by dt of negative IC, negative IR, plus V sub C. Okay. So that becomes L d by dt of negative, so I'll write it this way. I sub C minus L d by dt of I sub R plus V sub C. Like that. Okay. And as somebody just said, I sub C is negative C dV dt. That negative sign here, when I plug that in here, right, what's it do to the first term? When I plug I sub C into that first term, what's going to happen? Yeah, you get a second derivative. What's going to happen to the negative sign? It's going to cancel, right? This guy's going to become LC dVc dt squared. Like that. Now, I'm not sure quite what to do with the middle term yet. Okay. All right. So I sub R, what do I know about that? Okay, I'm trying to get to an equation for DC. Okay. What do I know about IR? Back to the original circuit. What do I know about IR here? Well, IR is equal to VL divided by R. Right? And VL is what? How is VL related to everything in this circuit? Well, we got a KCL here, right? Or sorry, KVL. That tells me that VS equals VL plus VC, right? So what's VL equal to?
Yes, minus VC.
VS minus VC. So I also have this whole thing here, right? So we just said VR equal, or sorry, IR is equal to VR divided by R. This is VS minus V sub C all over R, like that. I could plop that into here. Right, so that's going to turn this whole thing into, so VS is equal to LC so minus L times d by dt of 1 over R V sub S minus 1 over R V sub C plus V sub C. This is about as hard as it gets. All right. It's like, I can't imagine I would ask you something much more difficult than this. All right. This is looking good, isn't it? Getting there. All right. So that middle term is a derivative there. So a derivative of a constant and a derivative of V sub C. What's the derivative of a constant? 0. Right? So the derivative of the voltage source, V sub S, is 0. And then what's going to happen to the V sub C term? You're going to keep its first derivative, and the minus signs are going to cancel out. Right? And so you're going to end up with V sub S equals LC dVc dt squared plus L over R dVc dt plus V sub C. Okay. Basically saying that the derivative of this basically becomes 0, and the two minuses there cancel each other. The minus L times minus 1 over R cancels. All right, and I'm left with that. Now, is that in the standard form? It's close, right? What do I need to do? Divide by LC. So this guy becomes V sub S divided by LC equals D squared DC dt squared plus 1 over RC dVc dt plus V sub C divided by LC. All right. So that's actually, pretty similar to a lot of the other sort of equations that we get in this case. All right. Questions about how I got there? Perhaps many. Yeah. You could follow me doing it, but could you do it yourself? Yeah, like I said, that's about as hard as it would get. But I mean, the reason I went through that process, right, is in general what you're going to end up with when you do your analysis, and I suspect what you see on the exam, you're probably going to end up with LRs and Cs in series, or LRs and Cs in parallel, in general, right? You may have something weird that I give you with some switches like this, but I suspect it'll end up being like a series or a parallel, probably, type of thing. Okay. That's not to say this isn't. Those are very common circuits. Like in reality, there's a lot of places where they come into play, right? This is a circuit that could be built, but is probably kind of strange. Okay. You guys follow the process there? The key thing, really key thing of all of this stuff, right, is like I did here where IC is negative. Make sure you write everything down consistent with like the whole passive sign convention, all that kind of stuff, right? That's really important. All right, I gotta make sure I do that. Okay, so I got to here and I didn't have any numbers, so now I gotta start making up some numbers. Because my step 2 is to figure out whether this is underdamped or overdamped. Now I am gonna make up numbers for this thing eventually, but my sense is that that part should be pretty straightforward for you guys. Once you get to here, right, you can probably figure out your alphas and omegas and do that. All right. We'll come back to that. Key thing probably is the rest of the steps, right? So in particular, I think probably the step where you're trying to figure out the derivatives at 0 plus. Okay. So let's skip ahead. Let's skip past step 2. Let's go to step 3. What is step 3? I think my step 3 is finding the final conditions. All right, so the final condition. So basically VC of infinity and IL of infinity. So how do I do that? Inductor becomes a short, capacitor becomes an open, right? So what's that going to be? All right, so step 3. Step 3 would be, now actually before I get onto that one thing real quick. On the second derivative, the first derivative, and the 0 derivative, I call this guy always the 0 derivative. There's basically d by dt to the 0 power. So sometimes we call that the 0 order derivative. All of those are positive, right? They always all have to be positive. It didn't look like it was going that way for a little while, right? But so like in other words, when I got to here, it was trending badly. I had some negative signs in there, but they went away. Why did they go away? Because I was careful ultimately about this relationship. Based on the way I wrote things, I had to make sure that I wrote the I equals C dV dt and V equals L di dt consistent with the signs that I drew. All right. I see you guys not do that all the time. And I see you guys change your mind about what you're doing all the time. All right. Those you can't change in the middle. Once you've set the directions, you can't change them. Like in other words, I see people set directions like this. And then later on in the problem, like when they're solving for like the initial conditions, they'll do it a different direction. That's going to give you the wrong answer. Once you've chosen them, you can't change. Okay. All right. So, all right, just make sure you get to that. If you get to the point where if you get on the exam and one of the terms is negative, make it positive and move on. Because I'll give you credit. If you don't get hung up, this is an exam thing for you guys. If you can't get this equation here, don't get hung up on that. Move on. All right. And solve the rest of it that you can solve. Right. Maximize your points. All right. Don't get discouraged if you don't get this. Yeah. Chances are it's going to always usually look like something like this anyway. Something's negative, just make it positive and move on. All right. And you'll probably be right. Okay. And you'll lose some credit for getting the differential equation, but you'll get the credit for the rest of it if you can do it. Okay, that's my point. All right, step 3 was to get the final value. So the circuit looks like this. Here's V sub S. There was L here. There was R here. And then there was the capacitor. So the L became a short, the capacitor becomes an open. All right, so this is V sub C of infinity. Here's I sub L of infinity. Like that. Okay, so what's V sub C of infinity and what's I sub L of infinity?
Yes, and you're.
Yeah, this guy is V sub S. This guy is 0. Wait, he's a short circuit. How can a short circuit have 0 current? There's no path for current to flow in this circuit, right? So KVL basically tells me if I do KVL, V sub S is equal to whatever V sub C is. All right, you guys follow that? If there's no path for current to flow, there can't be any current. There always has to be a closed loop for current to flow, right? All right, step 4, what's that? Step 4 is to find the initial conditions, right? So really what I need to find here, this is a case, and I'm going to like these probably, where I need you to find for me. I think for a lot of the problems, I gave you what V sub C of 0 minus was and what I sub L of 0 minus was. Why? Because I was just being lazy and I didn't want to draw a more complicated circuit. But I have a feeling on the test, I will ask you to find those values. All right. So I need to find V sub C of 0 minus and I sub L of 0 minus. So how do I do that? When I say 0 minus, what do I mean? It's right before the switch moves, right? Right before the switch moves, which means I was in a steady state. If I was in a steady state, what's true about L and what's true about C? So in steady state, L is what? Always. L is a short and capacitor is an open. Like that. Okay. All right. So right before the switches moved. Okay. So I had a weird looking circuit. All right. So before t equal to 0, what were the switches doing? Before t equal to 0, this switch over here, right? That's closed. And this switch over here was closed too, right? Okay. So in this case, what do I have? I guess I'm going to draw it here. So I have my L, my R, my C, and then I think I have, what did I have? I had a current source here, and I had a resistor over here, like that. Okay, this was R, this was L. Okay. Now, we said this was a steady state. I just drew it this way just so we could. Right, this is basically what it looks like with the switches being the way they are. All right. So this is, just to be clear, this is before t equal to 0. Okay. But since I'm in steady state, how can I simplify that circuit? What's true about the L and what's true about the C? What's that? L is short and C is open, right? So basically, what do I have? I got basically a resistor in parallel with an open. There's a open there, current source, and resistor R2. Here's R, right? Okay, so what am I after? I'm after IL and I'm after VC. Okay, help me out. VC is the easy one. What's that? 0. How do you know it's 0? If I do a KVL around the circuit here, I'm going to see that the voltage there has to be 0, right? The loop I could do basically would be this loop. Right? Tell me that voltage around that thing is equal to 0, right? The voltage across the resistor is 0, and the voltage across that capacitor is 0. The thing I want to be careful about, and this is the point I was trying to make earlier, I defined the direction of I sub L and V sub L and all that stuff before, right? So how did I define how did I find all those directions? Well, V sub L was this way, right? I sub L was that way. V sub C was this way. And I sub C was that way. I can't change them. That was the decision I made at the beginning of the problem. I can't change them. You're going to make a mistake if you change those, right? Everything has to be consistent with that. All right. So knowing that, here's I sub L of 0 minus right here, right? What is I sub L of 0 minus? So I have a current divider here, don't I? So I have so look at that circuit. I have, and this is something some of you guys probably want to talk to me about problem 3 on the exam. That's probably where I suspect some of you went down in flames. I have a current divider here with 3 resistors in parallel. Who agrees with that statement? I have 3 resistors in parallel right here. How can I tell that things are in parallel? Well, I could do that. Yeah, I don't like saying that share the same node business, right? The voltages across them is the same. Because you can easily, if they only share one node, they may not be in parallel. All right. In this particular case, R, R2, and a short are all in parallel with each other, right? You guys see that? Right? So if I have 0 ohms in parallel with R and R2, what's the parallel combination of those things? 0, right? So this guy is a current divider, right? And so where's all the current going to go? It's going to go through the short, right? And again, if I can't tell that, if I'm trying to figure out, okay, I sub L, first of all, I sub L of 0 minus, I use the current divider relationship, which is always basically the voltage. So it's I sub S times the parallel combination divided by the resistance I'm going through, which sounds mind-boggling, but 0 divided by 0 is 0. Sounds weird, but it's 0. All right, that's how I'm seeing it mathematically. But the way you guys think about this is current. Which path does current like to take? It's just like you like to take the path of least resistance, right? So it's I do too, right? So the path of least resistance here is 0. But the way to think about that, I think of it as a current divider. Current has the option of dividing. It's going to take its path down that 0 resistance path. Okay. And there's a problem with what I wrote here because there should be a negative sign, right? Negative I sub S. I sub L of 0 minus is negative I sub S. That's the kind of thing that you guys make a lot of mistakes on in the homework, right? So why is it negative? And you're going to make mistakes on it because of this. because why is it negative? Because I sub L, the way I defined I sub L was to be going from left to right at the beginning of the problem. And I sub S, this current is going to end up going that way against the arrow, right? So I sub L is equal to negative I sub S, right? That's the kind of thing that if you're not paying attention to your directions, I see a lot of people say I sub L is equal to I sub S, right? But you got to stay consistent with the direction that you chose at the beginning. Okay. All right. So that was a long way of saying we have V sub C of 0 minus is 0. I sub L of 0 minus is negative I sub S. Okay. Now, the other thing as part of my step 4 is I say V sub C of 0 minus and I sub L of 0 minus. What are those always equal to? The value of the capacitor voltage at 0 minus. How does that relate to the value of the capacitor voltage at 0 plus? Same, right? And I sub L 0 plus. So this is negative I sub S. This is 0. Now, step 5. Basically, the laws of nature, right? The laws of thermodynamics made it that those statements always have to be true. Now, the thing to solve a differential equation is I always have to get a derivative result. So in other words, I need to get dVc dt of 0 plus. And I need to get dIL by dt of 0 plus. Okay, so what are these things? Well, I have I sub C is equal to C dV dt, and V sub L is equal to L di dt. Okay, so what I have to do in step 5 is I have to solve for IC and VL at time t equal to 0 plus. What does that mean? What circuit do I draw at 0 plus? And why do I keep doing this crap with 0 minus and 0 plus? Why do I do this crap? To confuse you? Not on purpose. I know it confuses you, but I don't do it on purpose to confuse you. Why do I do it that way? What's happening at t equal to 0? Switch is moving, right? So it's kind of not clear. Is the switch open? Is the switch closed? I don't know. It's in the movement process, right? So what we do is we say, okay, well, let's look at it as 0 minus, and then let's look at it as 0 plus. All right. And so we're careful about doing that. So 0 plus, what's true about all the switches? They are in whatever state they are in for t greater than 0. That way it just removes any ambiguity. All right. So basically the circuit that I have is whatever the circuit was for t greater than or equal to 0. Okay. So I have this. I have my circuit is V sub S L R and the capacitor. Okay, well, here's IC. And so let's be clear, this is IC of 0 plus. This is VC of 0 plus. This is VL of 0 plus. And this is I sub L, also 0 plus, like that. Okay. All right. I drew a bunch of crap. What am I looking for in the end? I'm trying to find the derivatives, and the way I'm trying to get them is I want to find VL and I want to find IC. Okay, that's how I'm going to get those things. All right. In this step, I'm worried about the transition from 0 minus to 0 plus. And what do we know about the capacitor there? If VC 0 minus is equal to VC 0 plus, then over this really, really short time, what's true about the capacitor? It's a voltage source. All right, so this is the key thing. From 0 minus to 0 plus, right? I have that the capacitor is basically equal to a voltage source, V sub C, whatever I had at 0 minus, okay? And the inductor is equal to current source based on whatever value it has. In other words, basically what we're saying is the inductor current's stuck at that value. Capacitor voltage is stuck at that value. So I can think of them as sources. Okay. How the heck does that help me in the rest of this problem? What do I do with, so we look at the circuit here, right? This circuit. What do I do with the inductor? What do I do with the inductor? And make it a current source, right? In which direction does that current go? All right, your directions are opposite of my directions, right? It's going the opposite of the arrow, right? So it would be, boy, I really want to draw these next to each other. Let's see if I can fit it here. This is V sub S. The inductor becomes a current source go in this direction. I could have also drawn it as a current source going the other way with a value of negative I sub S. All right, but I drew it this way. And what do I do in this particular case with the V sub C? What do I do with the capacitor? It's a voltage source, right? It's a voltage source with 0 volts. A voltage source with 0 volts is a short circuit. Okay, so there's a short there. And I sub C was defined to be going this way. I sub C is going this way. All right. This is a weird one. Like that. Okay, this is definitely a weird one here. What do I have here? What is going on here? Ooh. I created a weird circuit. Yeah,
Can you explain why IS is going to the left when IL is going to the right?
because that's a great question. I'm glad you asked, right? Because I think a lot of people are missing over that one. And this is the kind of stuff that's going to cause you to lose those little ticky-tack points that'll add up on the test, right? IL is negative IX. So if IL is going that direction, I put a current source going the opposite direction. That doesn't, so I found in the previous part, right, that IL is equal to negative IS. Right. Now, the other thing I could have done if I wanted to is I could draw it like this. I could say it's going that way and it's negative IS. That's fine too. That's an equivalent statement. I reversed the arrow in that current. Right. All right. This is a good one because this one's gonna. All right, here's V sub S. I don't like I sub S going this way. R is going this way. All right, capacitor voltage is 0. Okay. And oh boy, here's R and here's V sub L. That's 0 plus. Okay. All right. Boy, I want to find I sub C of 0 plus and V sub L of 0 plus. They're both tricky. All right. You got a question or a
I
statement?
was gonna recommend how to do it, but I'm not right.
All right. Well, give me a recommendation.
So I'd say you transform the parallel combination to a voltage source in series with a resistor. And then you can find the total voltage across that resistor and then find the current.
I don't want to do that. Yeah, maybe I could. I'm not sure I follow you, but I don't want to do it, even if it's right. I'm just going to do a KVL around this loop here. So if let's say I want to find V sub L of 0 plus. Just do a KVL to tell me V sub L of 0 plus. What does that got to be? What's the voltage across the inductor? What's that? VS. Yeah, it's that voltage source. Right? Yeah, I mean, they're in series with each other. Yeah, but if I just did a KVL, right? So KVL gives me 0 equals minus V sub S plus V sub L 0 plus. Okay. So I've got the voltage across the inductor is equal to whatever that voltage source is. Now, here is the one that is probably going to rattle your brain a little bit. What's I sub C of 0 plus? Maybe it all rattles your brain, but this one definitely should. What's I sub C of 0 plus? How do I figure out that? Well, let's go to my old friend KCL. I can do KCL here, can I? At this point, right? I can do KCL at that point. And we said that this was IL, this was IR. Okay. So help me out here. In terms of IL, IR, and IC, how do I write KCL? Which currents are going into the node? All of them. So IL plus IR plus IC is 0. What's I sub L? It's negative IS. Why did I say negative IS? Why was that negative IS? Because IL is going opposite direction of IS. Okay, that's negative. What's I sub R? What is it? What is I sub R? It's a resistor. So how do I figure out the current in a resistor? Voltage divided by resistance. The voltage across it is V sub S, so it's V sub S over R. And I sub C of 0 plus is like that. That's all equal to 0. Oh boy. So what does that tell me? That tells me that I sub C of 0 plus has to be equal to Vs over R minus I sub S. Right. And again, I have, you guys probably don't like it. I haven't put any numbers into this, but all of those things would have numbers.
Would it be negative Vs over R plus IS?
Oh, wait, did I do my signs wrong? I did. Yeah, sorry. This would be negative, and that would be plus. Yeah, thank you. All right. Yes. All right. So, yeah, I mean, these guys would all have numbers that would be associated with them, right? So, I mean, we could make up numbers here. Let's say we had I sub S is, I don't know, 1 amp, and V sub S was 10 volts, and L was equal to a millihenry, and C was equal to 1 microfarad, and R was equal to 10 ohms. Okay, then I would have a number for that thing, right? And I can go back now and figure out if it's underdamped, overdamped, all that good stuff. All right. Now, since I solved for VL of 0 plus, and I solved for IC of 0 plus, I could then go back and solve for, so okay, we did a long-winded thing here. What was I doing this for? To get the derivatives. If I have IC, I can get C dV dt. If I have VL, I can get DI by dt, right? That's the whole reason why I was doing that. Now, the last step is to combine all that stuff. In my view, that's a math step, all right? So step 2, I didn't do because I was lazy and I didn't make up numbers, right? But that's a math step. I think you guys are good with that, all right? Step 6 is a math step. You guys should be good with that. It's the other ones, step 1, step 3, step 4, step 5, which are circuits, right? And that's where I think you guys are probably the weakest. Okay, all right. Yeah.
This may be a dumb question. Can you just find that V of R and substitute that in for V of L?
Could you, for what part?
Or V of L to just find V of R and V of L.
Yeah, yeah, and technically we've been doing that throughout the problem, right? So we back to the very beginning of the problem, we made that statement V sub L is equal to V sub R. And that's kind of what I did, right? When I found V sub L, I found I mean, they're equal to each other. This would also be equal to V sub R. Knowing that doesn't necessarily make the problem any easier, but yeah, they're equal to each other. So. All right. I really, those 2 videos, again, if you go to my YouTube and you go search, I think it's all probably chronological, right? So the 2 examples that I posted for lecture or for recitation last week, those are back in 2021. So if you're looking for them, you wouldn't find them in order. So again, on the Canvas page, they're laid out, and I would look for them there if I were you. Okay. This is again, this is more complicated than I would give you on exam, but this was really good practice. I think if you can think through this one, this is about as tough as it would get. Okay. What I suspect I will do on the exam is I'm very likely to give you something like this, where I've got switches that are moving around for 0 minus and 0 plus. That way I know you have to think about the conditions. All right, and that's good circuit practice. Okay, so I'm gonna stop there. If you guys have any questions at all, just feel free to come up.